In this following activity, we will discuss some examples related to Lorentz magnetic force on a charged particle. Over here, there are certain examples which I have written, and this first example will be a positive charge in which it might be a proton, and another charge will be a minus charge, and all these charges are moving with certain velocities indicated by these vectors. We know from this Lorentz magnetic force, this Lorentz magnetic force is given by this equation, okay, BQV sine of the angle theta, where V is the velocity of the charged particle, Q is the charge of the particle, and B is the strength of the magnetic field. Now when you look at this particular figure, we see that there is the direction of the magnetic field vector which is moving on this direction. So I want to find the direction, okay, I want to find direction of this positive charge from this first figure. So what do I have to do? We will apply certain laws to find out. So I will apply the right hand thumb rule, okay, the right hand thumb rule and this palm rule. So what will I do in order to get the direction of this charged particle plus Q, which is moving in the direction which is perpendicular to the field. So from here it is evident that this charge is moving in the direction of 90 degree. So from here it is obvious that V is proportional to B, okay, V is perpendicular to B. So if V is perpendicular to V, so from here if we find out, that means if we substitute angle over here, this angle will be equal to 90 degrees. So it is evident that this magnetic force will be maximum. This is only for finding what? This is only for finding the magnitude. But if we want to find the direction, since a force is a vector quantity, we have to also find the direction. So making use of the right hand for positive charge, okay, for positive charge we'll make use of the right hand, okay, we'll make use of the right hand palm rule. So first I will teach you how to use the right hand palm rule. So from here, making use of this right hand, okay, I will align these fingers, indicates the direction of in which the velocity is moving, and then I will curl my fingers in the direction of B field to give me the direction of where the thumb is pointing. So first I will align along the direction of the velocity vector. So when I align along the direction of the velocity vector, which is indicated by this V, that means this is the correct position of the velocity with which this charge is moving. Then I have to orient my fingers. I have to rotate my fingers in the direction of B. But if I rotate in this direction, that means this is the faulty direction with which B is operating. So you have to arrange your fingers in such a way that it is in the correct position of what? Of V. So this is the correct position. So V is moving in this direction of that positive charge particle. Then when I align the finger on this direction with respect to the direction of V, then this thumb, your thumb is pointing downwards, so which means that the force on this particle is acting perpendicular and downwards. So if it is acting perpendicular and downwards, which means that this force, okay, the force acting on the particle will be perpendicular and downwards. So that is why I will represent by the cross mark. So again, making use of this right hand thumb rule, I will apply in this is the direction of the velocity vector, and then I will curl my fingers in the direction of B, then the direction in which the thumb points, that will give you the direction of the force F. F is perpendicular and downwards. Next, we will find out what is the magnetic force for the particle, for this negative charge particle. So for the negative charge particle, we will make use of the right hand palm rule. Okay, we will make use of the right hand or the left hand palm rule. So by making use of the left hand palm rule, in this case also, I will take my left hand. All these fingers will indicates the direction of the velocity vector, and then when I rotate my fingers in the direction of B, then the direction in which the thumb point, that will give us the direction of our magnetic force F. So over here also, for the negative charge, I will make use of the left hand palm rule, and for the positive charge, I'll make use of the right hand palm rule. So since this is negative charge, I will make use of the left hand rule. So I will point my direction, I will take my left hand, point my fingers in the direction of V, then I have point my fingers in the direction of V, then next I will rotate in the direction of B, then the direction in which this thumb will point, that will indicate the direction of that will indicate the direction of your magnetic force. So the magnetic force for this negative charge, since the thumb is pointing upwards, so this will be indicated by F, so that force will be pointing upwards. It is indicated by this dot. So force in this case is indicated by the dot. It is what? Perpendicular and upwards. And over here the force is indicated by the cross. This force is indicated by the cross, so this will be what? This will be perpendicular, perpendicular and downwards, down into the page. Okay, down into the page. This will be down into the page, this will be up into the page. So again, if you make use of your right hand rule for positive charges in the direction of the velocity vector, and then curl your fingers in the direction of B, then the thumb, this thumb is pointing downwards, so that will give you your direction of your force. Another important thing is by making use of the left hand, the left hand rule and the right hand rule. So for the left hand rule and right hand rule, for the left hand rule we make use of this direction. So from here we know that if you outstretch your fingers in the direction of all these directions, that means this will be the central finger, the index finger and the thumb. Okay, so this thumb will indicate the direction of the force, field, direction. So this will give us the direction of this will give us our direction. Okay, that will give us our direction, and this will give us this will give the direction of the magnetic field. So force, field and direction. Force, field and direction. So from here, with respect to the positive charge, that means if I want to find the direction of the force, so from here I will align like this, since this is the force, field and this is your direction. So from here, making use of the left hand thumb rule, okay, that is the direction in which the velocity is moving, and this is the direction in which the field is moving. So your thumb is pointing downwards. So making use of this rule, Fleming's left hand rule, this is Fleming's left hand rule, we can find the direction of your magnetic force. So for making use, so from here you can make use of the palm rule, or you can make use of your Fleming's left hand rule, like I have been demonstrating in this. So from here also we can use of the right hand. Then over here you can make use of the right hand rule. Okay, right hand rule for positive charges. For positive charges you use your Fleming's left hand rule. For negative charges, that means you will make use of the right hand rule. So from here, if it is negative charges, I'll make use of the left hand. That means the thumb indicates the field, this will be the direction. Okay, this will give us our direction, this is the direction, and this is the field, this is the field. Okay, this will give us the field, and this is your direction. Then from here, the direction, since this is the direction, that means this is the field and that is your direction. Okay, this is the field and that is your direction. This is the field, this is the direction of the magnetic field, and this is your direction. Then making use of the right hand Fleming's rule for negative charges. Over here I will align my fingers in the direction of in the direction of your movement of negative charges. So the negative charges is moving upwards, and this field, okay, is pointing in the direction of B. So the thumb is moving upwards, so that is why this force is moving upwards. Okay, whereas in this case the force is moving downwards. So similarly you can do for different cases for finding the direction of B. Next, another example. In this case, we have, this is the direction of our B field, and this is the direction in which the charged particle is moving. Over here, this is your positive charge. So which means that over here, the angle between V and the angle between B are acute in nature. Okay, are acute in nature. Why I say acute in nature? Because this will give us the direction between the v vector and the b vector, velocity vector and the and the magnetic field vector. So since this is the positive charge, finding the direction, we can make use of the right hand palm rule. So first I will point my finger in the direction of V. So I'm aligning my fingers in the direction, this is my right hand, this is my right hand. For positive charge, make use of your right hand. For negative charges, you make use of your left hand. So for positive charges, finding direction, I'll make use of the left hand, point my fingers in the direction or stretch my fingers in the direction of V. Then since this is the direction of B, I will orient my fingers in the direction of B. Then my thumb is pointing downwards, so which means that the magnetic force on this positive charge particle is pointing perpendicular and downwards, indicated by cross mark. Next example, this is, okay, you can find out that this is the direction of the magnetic field and this is your negative charge. The negative charge is moving downwards, so I will make use of the left hand. So outstretch your fingers in the direction of B, outstretch your fingers in the direction of your V velocity vectors, then curl your fingers. Okay, curl your fingers. So from here, when you outstretch your fingers in the direction of V, and then when you curl your fingers in the direction of B, okay, first this is in the direction of V, this is the negative charge, this is the left hand. So for the negative charge, you use your left hand in the direction of V. Incline your fingers in the direction of V. Then rotate your fingers in the direction of B. Then this thumb is pointing upwards, so which means that the magnetic force in this case is perpendicular and upwards. In this case, the angle between V and B, this is the angle between V and B, this is your B vector. It is how much? It is 90 degree. Next, another example. Okay, over here we have the negative charges and this charge is moving on this direction, but it is also evident that over here the direction between V and B, it is obtuse. Okay, that angle is obtuse, which is more than 90 degrees. So from here also, since this is the negative charge, you have to make use of your left hand palm rule. So by making use of your left hand palm rule, okay, I will align my fingers in the direction of V, then I will rotate my fingers in the direction of B to find the direction of your magnetic force. So from here, first in the direction of V, and then curl my fingers in the direction of B. Then this thumb is pointing upwards, so which means that the magnetic force for this particular example will be perpendicular and upwards, indicated by the dot. Next, for this particular example, okay, when you look with respect to the direction of V and with respect to the direction of B, so it is obvious from here that this is the direction of the velocity vector and this, okay, is the direction of your magnetic field vector, which means that the angle between them is how much? The angle between them is 180 degrees. So if you make use of that formula, okay, F equal BQV sine, okay, sine of 180 degree, we know that sine of 180 degree will be equal to 0, which means that magnetic force will be equal to 0, which means that over here for this particular example there will be no magnetic force. That means this particle will just move swiftly in this upward direction. So this is, watch out for this particular example. Another example is that I have written these dots. These dots indicates that the magnetic field, okay, the magnetic field is perpendicular and upwards, okay, perpendicular and upwards, which means that you have the north pole of the magnet down and you have the south pole on top. So the B fields, okay, the B fields are moving in this direction, indicated by these dots. So you have the positive charge. This is the positive charge. The positive charge is moving in this direction. So if it is a positive charge, make use of your right hand palm rule. So over here, this is the direction of, since this is the dots, this red pen will indicate the direction, or this blue pen will indicate the direction of the magnetic field, okay, which are moving upwards. And since this is the positive charge particle is moving in this direction, so let me indicate by this vector, which means that over here the angle between this B, okay, the B field, the angle between the B field and the angle between between the velocity vector, this angle is how much? It is 90 degrees. So you will expect that there will be magnetic force. So from here, making use, since this is a positive charge, making use of the right hand palm rule. So from here you have to do like this. Then if you do like this, if you outstretch your fingers in this direction, that means that will be the wrong orientation of the field. So how will you do? That means you have to do like this. Then this will be the direction. This will be the direction in which the velocity of the positive ions is moving. And then since the magnetic field is perpendicular and upwards, so first you align the fingers of your right hand in the direction of V, then you curl your fingers in the direction of your B. So this thumb is pointing in this direction, which means that your magnetic force, your magnetic force due to this particle will move on that direction. So it will move in that direction. So it is perpendicular to the plane containing V and B. Next, for this negative charge particle, we have these cross. All these cross indicates the direction of your magnetic field, which are perpendicular and downwards. So which means that the B field are moving this direction of the magnetic field. The direction of the magnetic field is perpendicular and downwards, or into the page. Perpendicular and downwards, or into the page. So from here, since it is the left hand, since it is the negative charge, make use of your left hand. So the left hand will outstretch your fingers in the direction of B. So if you curl like this, that will be wrong orientation of your field. So how will you do? You have to align your fingers in this direction. This is the direction of your velocity vector. Then since the B is pointing downwards, then you rotate your finger in that direction. So first in the direction of V, then second rotate your finger in the direction of B. Then this outstretched finger, this outstretched thumb will be the direction of your magnetic force. So your magnetic force will act in this direction. Similarly for this, since this over here also angle will be 90 degree. Even over here also, since dots, all these dots indicates the direction of your magnetic field. The magnetic field are perpendicular and upwards, and this is your direction of your B field. So how will you find the direction of the magnetic force? The direction of the magnetic force, since it is a positive charge, make use of your right hand. So point your fingers in the direction of your B field. So I will point my fingers in the direction of my B field. So this is the direction, correct position of the velocity vector. And then since the magnetic field is pointing downwards, so I will point my finger downwards. So from here, this is the direction of V, and then I will point my fingers downwards. So my outstretched thumb will be on this direction. So which means that your magnetic force will move on that direction. So lastly, there will be some other activities. So for a negative charge, you make use of your left hand. Since this is the negative charge, it is moving on this direction. You have to see, if you curl your fingers like that, that will be the wrong direction of B. So I will take my left hand on this direction with respect to this activity. That means I will first align my fingers in the direction of velocity vector. These fingers are stretched in the direction of V. Then I will rotate in the direction of B. So I will rotate in the direction of B. So my thumb will point downward, which means that this magnetic force, that magnetic force will be perpendicular and downward. So this will be your negative charge particle will move perpendicular and downwards. Next, this is the positive charge. Make use of your right hand. The B field is downwards. So from here, if you rotate like this and if you rotate like that, that means wrong direction of B. So you have to properly adjust your left hand on your right hand. So from here, this will be the direction of V. This will be the correct or direction of velocity. Then rotate in the direction of magnetic field. I will rotate in the direction of magnetic field. My thumb is pointing upwards, so which means that this magnetic force due to this positive charge particle will be perpendicular and upwards. So over here, your charge particle will move perpendicular and upwards. Similarly for this, since this is your negative charge, then you have to align my fingers in this direction. Align my fingers on this direction. This is my left hand. For negative charge, you use your left hand. Point your fingers in this direction, Then if you rotate like that, that'll be wrong. Your B field is moving downwards, so you have to orient like this, and then outstretch your fingers or rotate your fingers in the direction of B. Your thumb is pointing downwards. First, direction of velocity, then next direction of B, then your thumb is pointing downwards, which means that the magnetic force is perpendicular and downwards. For the other part, okay, you have the magnetic field which is perpendicular and downwards. Since it is the positive charge, you have to align your fingers in the direction of V. Okay, align your fingers in the direction of your velocity vector. Okay, velocity vector. Then with respect to this B, that B, your B is downwards, perpendicular and downwards, then you curl your fingers in the direction of V again. That first in the direction of V, velocity. Then next with respect to magnetic field, then your thumb is pointing upwards, which means that your magnetic force, okay, on this positive charge particle will move perpendicular and upwards. For the other part, this is your negative charge. Make use of your left hand. So the negative charge is moving in this direction, but your B field is perpendicular and upwards. So I will have to place my finger in this direction. Okay, place my finger on this direction with respect to direction of V. Then my magnetic field is perpendicular and upwards. So I will outstretch my fingers in the direction of B. Then my thumb is pointing on this direction, which means that the force is moving on this direction. Magnetic force is moving on this direction. Lastly, for this positive charge is moving on this direction. So I will take my right hand. Taking my right hand, place in the direction of V, and then magnetic force, okay, the magnetic force in this case is moving perpendicular and upwards. So if you rotate like that, that means this is perpendicular and downwards for this direction. So I will have to place my fingers in this direction. Positive charge, right hand. Then first you orient in the direction of velocity vector. First you orient your right hand in the direction of the velocity vector. Then since this magnetic field is perpendicular and upwards, so you curl your finger upwards. So this thumb, your thumb is pointing downwards, so which means that your magnetic force is pointing, the magnetic force experienced by this positive charge will be perpendicular and downwards. So these are the different types of cases where we can find the magnetic force of a positive charge and of a negative charge by making use of Lorentz magnetic force to find the direction of the different charges. Thank you.